Welcome to today's tutorial on mesh current method. Today what we'll be doing is how to use the mesh current method to find current in a resistor. Okay, so let's draw a simple circuit. Let's use this circuit to understand the concept of the mesh current method. So in this circuit, let's say we have resistor 5 ohms, 2 ohms, 10 ohms. Let's give this voltage 20 volts, and let's give this voltage 8 volts. So you'll be given a circuit and you are asked to use the mesh current method to find current in all the resistors. In this diagram, we can't straightforward use the network reduction, the series parallel, because the sources are 2. If you have a circuit and there is only one source, either at the end or inside the circuit, then we can use the series parallel combination. But we have 2 sources, so we can't say we are standing here and say this and this are in parallel while there is another source there. So we can't use the network reduction approach we've done so far in this circuit. So we are going to use the mesh current method to find current in all the resistors here. How then do we use the mesh current approach? From the name itself, mesh current. So what is a mesh? A mesh is a loop which does not contain any other loop. What do I mean? This is a loop, right? This closed portion here is a loop, and it's also a mesh. This one here is also a loop, and it is also a mesh. I have this whole portion of the network here as another loop, but it is not a mesh, because a mesh shouldn't contain any other loop in it. So if I consider all of this portion to be a mesh, it means it is containing another loop, this portion, inside it. So we say a mesh is a loop which does not contain any other loop. So in this diagram, I can say we have 2 meshes, but then 3 loops. I hope you get it. So let's see how we can use the mesh current method. So the name says mesh current. It means we are going to calculate for the current in the mesh. So the first approach is ask yourself, how many meshes do we have? We have how many? 2. So in this diagram, we are going to assign 2 mesh currents to each of the meshes. So current in this mesh, we can choose any direction that the current is flowing. If the question does not come with its own direction, you can assign an arbitrary direction to the current. So in this mesh, I'm saying there is a current moving clockwise in the mesh. So let's say there is a current moving in the clockwise direction in this mesh, and I'm calling it current I1. Let's say I'm in mesh 1, the first mesh, so I1 is the current there. Then you come to the next mesh, and that mesh there is a current moving in it. I'm calling that current mesh current I2. So I'm using clockwise here. For consistency's sake, I'll use clockwise direction here. Alright, so I have clockwise current I1 moving in this mesh, and another current I2 moving in that mesh. So you can ask yourself, what is the current flowing in this mesh here? It is I1. So that is I1, it is flowing on the branch like this. I1 is flowing clockwise direction, so it is moving through this voltage source. I1 is still on the branch, so I1 is moving through 5 ohms, and that I1 is coming down, moving through the 10. So I1's direction is in this mesh, and I2's direction is also in this mesh. It is moving through the 10. It is moving through the 2 ohms here, through the voltage source, then here. So I2 has its path in this direction. So if we ask ourselves, what is the current flowing through the 5? The current flowing through the 5 is I1, right? The current flowing through the 2 is I2. But the 10 ohms here is between mesh 1 and mesh 2. And we have current I1 flowing through the 10, at the same time current I2 flowing through this 10. So the current through the 10 is the difference between I1 and I2, because they are flowing in opposite direction. You could see that I1 was moving in this direction. So it's moving downwards in the 10. But then I2 is moving upwards. So you just find the difference between these two, and that will be the current through the 10. Alright, so we are going to find this current I1 and I2. How do we use it in mesh current method? So in mesh current method, we apply the Kirchhoff's voltage law, the KVL. We apply only the KVL in mesh analysis. So we are going to write KVL in each of the meshes you have. If you have 3 meshes, write KVL in each of them. If you have 4 meshes, do so. Okay. So in this diagram, we are going to write KVL in mesh 1. Then we write KVL in mesh 2. So let's say KVL in mesh 1. KVL in mesh 1. So KVL states that the algebraic sum of voltages in a closed path or in a circuit in a loop is equal to 0. That is the sum of the EMFs, that is the sources in the mesh or in the loop, is equal to what? The sum of the potential difference, the voltage drops. So we are going to sum the EMFs here, and it is going to be equal to what? The sum of the potential drops. So let's see how we can write it. You remember I said whenever we have a resistor and current flows through the resistor, there will be a voltage drop. The polarity will be based on the direction of the current. So you have plus and what? Minus. Good. So this is a voltage, an EMF. I have its source plus minus. But this 5 ohms is a resistor. When its current I1 flows through, then you have a voltage there. That voltage, where will the plus be? Where will the minus be? The current is moving in this direction. Right? So we have the plus here and the minus here. You come to this one too. If I2 is flowing in this direction, there will be a voltage drop across this, and I have the plus here, the minus there. So we will need the polarities of the voltage drop because we are going to sum the voltages in that loop. So when I come to this loop, I'm moving in what? The clockwise direction. Alright. Let's see, is this voltage going to be a positive or a negative voltage? There are 2 ways to find out. One way is that you can see we have plus and minus, okay? So we can say we are moving in clockwise direction. We will first enter the negative and leave the positive. So if we are moving from a negative to positive, it's like we are increasing. So it means there is a rise in voltage here. So if there is a rise in voltage, it means it becomes positive. But if there is a fall, that is we are from positive to negative, we are decreasing. It means the voltage will be what? Negative. So we can use that idea to write our KVL in this loop. So let's try the KVL. When we start from here, the voltage here, we are moving in this direction, we enter negative and leave what? Positive. So we are increasing. That is a rise. So a positive voltage, 20. We move to this one. The voltage across this one is what? IR. So 5 times the current, I1. But will the voltage be positive or negative? That's based on what? The direction you are taking. So if you are moving clockwise like this, we will enter what? The positive here, then leave the negative. So positive to negative, we are decreasing. So that is a drop in voltage. So it becomes negative. So minus the voltage here is 5 what? I1. Alright, we are in mesh 1. So I will need to sum this voltage, this, and the voltage across what? The 10. Very good, very good. So I'll come to this 10 too. But don't forget the current through the 10 is what? I1 and what? I2, the difference between them. So I am in loop 1. So I1, let's say I1 is the current acting because I am in loop 1, mesh 1. So if I1 is flowing through the 10, its polarity is what? Plus, minus. Because I1 is the current acting now. It is moving in this direction. Plus, minus. So what will be the voltage across the 10 ohm resistor? It is the resistor 10 times the current. But that current here is what? I1 minus I2. We are in mesh 1. So its current minus the current in the adjacent mesh. Good. But we know that it will be negative because I1 is going to enter positive and leave the negative. So that is a drop. So I'll have minus the resistor times the current. But the current here is I1 minus I2. So I have I1 minus what? I2 giving us what? 0. KVL. The algebraic sum of voltages is equal to 0. So I have 20 minus 5I1 minus 10I1 plus 10I2 giving us 0. We are just expanding this. We are expanding the bracket. So let's group our variables. We have minus 5 minus 10, so minus 15 I1 plus 10 I2 giving us what? Minus 20. So this is what? Our first equation, the KVL in what? Mesh 1. So our next job to do is to write KVL in the next mesh, which is mesh 2. So let's see how that KVL will look like. So let's write it here. KVL in mesh 2. KVL in mesh 2. So in mesh 2, how many elements are we going to consider? 3. So we have resistor, another resistor, what, and a voltage source. So we need the voltages for these 3 elements. Their sum is equal to what? 0. So we can start from any of the elements. Let's say we are starting from what? The 2. So if you are starting from the 2, we know the polarity, we have plus and minus based on the I2's direction. The voltage will be plus and minus. So we are moving from a positive, we are leaving the negative. So we can say the terminal that we are leaving will be the sign of that voltage. So since we are leaving negative, I can say it is a negative voltage. So I have minus 2 times the current I2. This is a voltage source, we have plus and minus. So we are moving clockwise direction. So through this one, I'll enter positive and leave negative. So that's a negative what? Voltage. What about this thing? We've done for this, we've done for that. It's left with this thing. And this thing, this is the one acting. So we have what? Now I2 is working because we are in mesh 2. So the polarity on this thing is what? Plus, minus. This one is working. So we are moving in this direction. We'll enter plus and leave where? Minus. So that is minus 10. And what is the current? We are in mesh 2. So mesh 2, the current is I2. That's the one working. So I2 minus I1, because we know the 10 will have I2 and I1. But since we are in mesh 2, its currents will come first. I2 minus the other current, I1. So I2 minus I1 giving us what? 0. Algebraic sum of voltages is equal to 0. So we can now expand. We have minus 2 I2 minus 8 minus 10 I2 plus 10 I1 giving us what? 0. So let's group our variables. We have 10 I1 minus 12 I2 giving us what? 8. And that is our second equation. We have 2 meshes, so we get 2 equations. One equation for each of the what? Meshes. So now we have the first equation which has 2 variables, I1 and I2. The second equation also has 2 variables, I1 and what? I2. So in this, we can solve simultaneously and get our variables I1 and what? I2. So you can solve it, but I will punch on the calculator. So solving this, I have negative 15, 10, minus 20. I have 10, minus 12, 8. So solving simultaneously, I will get my I1 to be 2 amperes and my I2 to be 1 ampere. When you solve simultaneously, you get I2 to be 2, sorry, I1 to be 2 and I2 to be what? 1. So now the current in the 5, because we were asked to find current in all the resistors. Current in this 5 is what? I1. So let's say current in what? 5 ohms is I1, which is 2. Current in 2 ohms is what? I2, which is what? 1 amperes. Current in 10 ohms is what? The difference between what? I1 and what? I2. Since no current direction was given on the 10, we can just find the difference and get the positive number. So check which one is bigger. You see that I1 is bigger than I2. So we can say current in the 10 is what? I1 minus I2, which is 2 minus 1, giving us what? 1 amperes. So this is the mesh current method approach used to find current in a resistor in a particular circuit. Thank you very much for watching this video.